Thank you. So I'm Youzhong. I work for a company called Mathworks. Today I'm going to talk about Idmapped mount support in OpenZFS and its application in our company. So it makes a big deal for our company, so that's why I'm here to talk about it. So a little bit about our company. I think many people know MATLAB, and not necessarily knows our company. Our company is called Mathworks, who created this MATLAB software. So we developed the mathematical computing software, MATLAB and Simulink. So around the world, we have like 5 million users in 180 countries, almost all over the countries. Wow. In the country, in the world, probably 190 countries, I think. So approximately 100,000 business, governments, and university use our software. So it's it's a very popular software in the academic area, especially also in the industry, you know. So a little bit background and motivation about this this work. So I work for the company in a group that support the product development. We basically design, implement, and maintain the infrastructure for the product development. We have hundreds of servers worldwide. The main file system we use is ZFS. Previously, we use Lumos, you know, and then we migrate to Linux for some reason. So in the CI system, there is a single raw account which own all the files and the folders. That's the nature of our CI system. So basically, in the CI system, we have a build area. You know, that area is huge. It's like 12 million files, 4 million folders, right? So each developer, they're going to work in a sandbox. Basically, when the CI system finishes, you get something ready. So developer can develop on top of this sandbox, right? So basically, we use a ZFS. It's a fantastic clone technology. You know, the clone can happen instantly. Basically, the developer get a sandbox. But the problem is the sandbox creation takes long time. We know the ZFS cloning is fast, but after that, we have to do something to make this sandbox ready for a developer. So here's a typical workflow. So on top of that, we have an origin, the ZFS dataset, and its snapshot, right? So this one has 12 million files, 4 million folders, and the clone for each developer, we clone from this origin. Each developer get a clone sandbox, right? And then after that, we have to change the ownership to the developer from the lower account to the developer. That clone process, it's not a big deal if you only have hundreds of thousands of files. But now you have to clone millions of files. So that's a challenge I have been facing for years, right? So, so here's a pain point. Basically, the clone, it's a bottleneck. Why? It's because the tree is huge. We have to clone from the raw account to the developer UID, basically. That's the only thing need to be done. After you change the ownership to developer, the developer can start to work. So for this clone, it's time consuming. It takes extra space because the ZFS copy on write, I think. And also it uses not so memory, not so memory. So here's a typical sample, a sample resource consumption. We run this on an idle test server, which has like a 1 terabyte of memory. We run 3 times. Yeah, it's an idle server. It takes like 3 minutes for this to finish. Memory, delta memory, you basically used after minus used before. Memory, like it takes like 70 gig, a huge amount of memory for this chunk to happen. Also the disk space, compared to the original sandbox size, 766 gig. Not many, but we have so many developers. We have to do this so many times on a server. That's a big deal. All right. So actually, you may ask, do you do the like parallel tuning? Yes, we do. Even with the parallel tuning, it's still slow. On a typical production server, it takes like 10 minutes, 20 minutes. Sometimes if the server is busy, 30 minutes. So basically, the developer want to start to work, they have to wait like half an hour. All right. So that's basically the kind of challenge you have been facing for many years. I joined this company in 10 years ago. So we have been facing this problem for almost 10 years. There are other groups who come up with some different approach, try to speed up this developer process, but it doesn't help much. So, so we have been asking this question many times. So why do we have to do this chunk? Is there any possibility we can just not doing this chunk, right? So the first thing we think about it, can we impersonate this role account ID? No. Impersonate the developer ID as a role account ID. We cannot do that because of the security reason, right? It's very simple. So next is it possible so that this role account ID can be magically mapped to this developer ID, right? This can magically happen. Why you have to do this chunk, So yeah. So we found this Linux feature which is called ID mapping. It's a fantastic feature introduced in the Linux kernel, in the ZFS layer, basically. So this is a kind of timeline. So in April of 2021, this ID map feature was available in Linux in kernel 5.12, done by a Linux developer, Christian, I think. And then, even before this April 2021, I think probably because of the release critical kind of that 5.12 release, somebody in OpenJS already did some work so that OpenJS can be compiled. So there's some preliminary work has already been done. But it's not plugged in to use this ID map. It's just so you can compare. So in December 2021, somebody filed a feature request, which is requesting this ID map feature in OpenZFS. I saw that feature request. Oh, I said, yeah, this is nice. So we should do it. It works perfectly for our company. So we started working. Well, not really. We wait for some time. We hope somebody will do the work. But it's been quiet for a few months, and then probably in March 2022, we started working on it. And in June, it's ready to be used in MathWorks. We tested, it just works perfectly for our use case. So this is a basic idea. In the developer, the Linux developer language, this ID mapping basically it changes ownership in a temporary and localized way, so that you have a ID translation, right, from ZFS layer to the namespace in the like ZFS storage space. So this translation automatically happens. So that's basically the way how the ID map works. So in our use case, we try to map the raw account ID to the developer UID in each data set in a cloned sandbox data set. Right? So now you don't have to do the churn. The file still appears, will magically appear to be owned by the developer once you have the ID mapping. But so that after this happens, right, the developer can make changes and create new files. But on the disk in ZFS, the UID or owner ID, it's still the raw account ID. So that's basically what happens here. So looking at that same workflow graph, right? So the clone still happen instantaneously. And then after that, for each sandbox, we set an ID map on the data set, and then we remount this data set using the provided ID map information. And then after that, everything just works. Well, once you have the ID mapping, when you do the file operation or you get attributes, that kind of thing, there's some kind of translation happen, but that translation very fast. So next I'm going to talk about the updates I have done to the ID map mount feature. I've gone through 3 basic iterations. So first is the status of ID map as of 2021. So it's ready in 5.12 kernel. And then at that time, it's available in ext4, ZFS, and some other file system, but no NFS server support. So no open ZFS support. Looking at the graph at the right side. On top of that, it's NFS server, right? NFS server, you call the VFS layer, and the VFS layer will call the file system driver layer. So the work is done in the VFS layer and also some file system driver layer, like ext4, ZFS. So the work for us, we have to do ZFS, NFS. For SMB Windows access, no need to do anything. Because the SMB or Samba person like SMBD see the file system as if the developer is sitting on the server, see the file system. So the first one is a basic support. This one basically, it doesn't work for container. The reason that in the container case, there's something missing in the kernel implementation. You have a namespace, file system namespace attached to the superblock, but it's not being used. So basically, this one, there's no kernel support, or no container support. If the container uses a different non-default user namespace, right? But it works perfectly for our company, for our use case. There's an example of the ID mapping. So Suppose we have a mapping basically 0, 1 million, 1 million. What does this mean? Means you map the ID in namespace, ZFS namespace, let's call it ZFS namespace, mapping the ID from 0 to 999,999. So 1 million IDs. You map those 1 million IDs to another 1 million IDs starting from 1 million to 2 million minus 1. That's so you map the ID in ZFS space to the VFS layer, basically it's kind of a user space. You can think that as a user space. So for example, if the UID in the ZFS is 110, right? 1,100, and then the ID in the VFS will be 1 million, 1,000, 1,100. So actually, you get the idea how this mapping works. So the kind of change I made to the ZFS, just take 2 examples. The inode operation, right? First is a create. So in the new kernel, the inode operation defined to take the mount namespace as a first argument. So basically, for each create operation, you have the ID mapping as an input. So now with that ID map input, you can do your translation. So typically what we do is here, first we have the credential. We get the current credential using current dash, right? And then in that credential, you have the UID, developer UID basically. And then you can translate the developer UID to the UID using the ID map to the ID which will be used in the ZFS. Yeah. Also other bunch of stuff like other like a maker, semi-link, bunch of stuff. And then the other way around, right? From ZFS to the username, it's like a get adder. Also, you have this the first argument as the ID map provided to this function, and then in this implementation, we just use a generic fair adder, that function, which is available from Linux. Yeah, it will make it to the work. So next change is about the support container. So our company is considering moving towards containerized our storage service. So basically, yes, that's why we did this work. But on the other hand, we also need to make this ID map feature works for any use case, right? So that's why we did this work. The basic idea is basically take advantage of the new kernel function which does this translation. So now instead of only have one ID map, now you have 2 ID maps to take care of. You have an MID map attached to the super block. You have another ID map for the mount point. So to use this feature, use this there's one for the namespace delegation, I think. You need this to use this ID map in a container. You want to map in a container. You dedicate the data set to the container, right? So kind of typical change, we've done this. We introduced 2 functions basically. One is convert the ZFS UID in the ZFS 9 to the VFS UID. There are also GID to VFS GID for sure, right? So this function takes three inputs. One is a mount ID map. Another is the file system namespace, the ID map. Sorry. So you have input as a UID from the user as ZFS space. So another one is the other way around, So you may wondering what this file system user namespace is from. It's from the inode. Inode has a superblock, and then in a superblock there is a user namespace. So here's an example with two ID maps. So here, basically, you can think there are three namespaces. One is a ZFS in the host. Another is a container namespace. And then you have this VFS kind of what the user is saying, kind of namespace. So that kind of translation happens when we do all the ZFS operation. Either you get data from ZFS or you write data to ZFS. I don't want to get into this. Let me go through this. So the first ID map, FS user namespace, right? You have a map from 100K, 0 to 100K minus 1, then map that to 100K all the way to 200K minus 1. Right? So the second is on the mount point, the actual ID map on the mount point. So that happened for the UID from 0 to 10K minus 1. And then map that to 10K to 200K minus 1, 20K minus 1, right? So this mapping, if you look at in the middle, so it's part of the file system user namespace. Right? So the last one I did is about the support the 6.3 kernel. So Linux did something. So they basically consolidated their ID map stuff, introduced a type def, which is hidden. Nobody can say it's failed. It's hidden type def. And then the GPL almost all the symbols. Yeah, like the default ID map, it's a GPL symbol. And also the conversion, those critical conversion API, they are also GPL. But the logic is very simple. You just do a translation, right? One to another, and use the second map to the translation. That's all happens in those conversion API, but they made it GPL. We don't want to get into this kind of GPL stuff. So what I did is basically, it's already written in the previous iteration. We did this, it's almost the same thing. The only thing did is use a new type def, right? So we have already done that, and now we do it in a new type def. So basically, we define our ZID map type definition, which is basically same as a mount ID map type structure, which is hidden. But to use a hidden structure, there's no way to use a hidden structure. So we define this mount Idmapped structure in our header file. It's no big deal. Just two fields, two fields. So for the new kernel, we define this. For the old one, we still define as a user namespace structure. Right. So it's almost like the same translation function. You take the first one as a mount Idmap, and second one as a file system user namespace. Right. So that's all we did. But in this one, this iteration, there are many changes. We have to take care of all the kernel. There are many if else, kind of thing to work around the to support all the kernel versions. Yeah, it's lots of changes. But recently, a few days ago, I tested this in the 6.6 kernel, I think. There's some funky stuff. So we may have additional work to do. Yeah, basically we are basically fighting with the Linux kernel. They keep changing things, and we have to keep up. So what's next? You may ask, people say how to use this Idmap, right? I didn't talk about this, how to use it. To use it, you have to mount it. Mount with provided Idmap information. That mount doesn't happen magically. So we internally, we did this work, which works perfectly for our use case. So in our use case, we basically, at the dataset creation time, we provide this Idmap information. Then we remount with the provided Idmap information. So basically, what we do is on the existing mount point, which is mounted by ZFS, we set a mount attribute, which is called Idmap mount attribute, provided Idmap information as a file display input to whatever the sys call. And then after that, unmount it, and then move the mount point. That's all need to be done to mount this dataset with the provided Idmap information. So what we didn't take care of is a case of like the following scenario. If somebody changed the Idmap from something to else, right? Something else, you have to redo this kind of work. We didn't do that. It's not our use case. But to upstream this change, we have to think about this kind of scenario. So in case of change the Idmap, what need to be done? You have to do unmount twice, basically. So first, you already have the Idmapped mount. So that one, you cannot simply change the Idmap information from one to another. You have to unmount it, remount it with no Idmap information, and then set the mount as a new Idmap file descriptor as a mount attribute, and unmount it, and move the mount point. I'm still working on try to simplify this, but yeah, still working in progress. But I mean, this kind of thing, I'm not sure if it can be done as a hackathon tomorrow. Tomorrow I'm not here, so it's welcome to do that. So all kind of the kind of logic is already available in a test utility, it's called Idmapped util.c. So in Linux, the mount utility also added a new option called x-mount.idmap. With that option, you can mount the dataset with the provided Idmap information. What I did is basically similar thing, but I think in the ZFS, code we have two options, right? Either we use a mount utility or we use a mount syscall. We have two options. Typically, we use a mount syscall, I think. So I don't think it's a good idea to use this X-mount Idmap kind of option available in the mount utility. So what we did, we introduced a user namespace, a user property called something Idmap, column Idmap. And so for this to be introduced into OpenZFS, I'm not sure if it should be the user property or system property. I haven't done this testing. If it's a system property, you have to think about the old version, new version, I don't know what happens, but anyway, it's up for research, So, how can I help? I think not many companies are using this Idmap thing. It'd be nice, so you can try this, try this in your use case, so that we can maybe identify some edge cases. In the ZFS code, there are so many places doing the ID kind of stuff. We may have missed something, who knows? So that's one request to the community. Second is this NFS support. We have an internal version basically to support this NFS server use case, because our client access the ZFS versions through the NFS protocol or SNB protocol, either from Windows or from Linux or Mac. So we have to do that. We had to do that work to support the NFS, but there's some challenge to upstream this this change because of the kind of licensing issue. We don't want to get into that kind of trouble. So maybe somebody can help, Any questions? Thank you.
One question. Remapping like a whole range, similar to like Samba's auto read mode or something. It seemed like it wasn't per like individual user. Like you have user 1, 2, 3, 4. The next one was 4, 5, 6, 7. It seemed like it shifted the whole range. Or is the ID map actually providing a number on one side and a number on per user basis, a whole table that you insert?
Yeah. So in our use case, we only map one ID. Well, actually, two IDs. We map the user ID, the role content user ID, and another one is root user. Is there some cases we need the root kind of access? If you don't do the root mapping, the root user will appear as an anonymous user. So we only do two mapping. But then after we roll out this feature in production, some people complain, I cannot write to a 777 file. Yeah, they complain because that user, he or she works in a sandbox which is owned by different user. And that user cannot make change to the 7755. And well, to solve that problem, it's very simple. So mapping UI, the door ID to the developer ID, right? And then for other ID, we do the identical mapping. That should solve the problem. Yeah. Without ID mapping, so the user is not going to perform any work.
Thanks, Youzhong.